All right, so I want to talk biomechanics in terms of torque or moment. Now, if we take a 10 kilogram dumbbell and we curl it through a 130 degree range of motion, and then we let it back down through the same 130 degree range of motion, we will produce a torque or moment profile that is the green for the concentric phase and the red for the eccentric phase. But if we use the AVR, where we can change the concentric resistance from 10 kilogram to 12.5 kilogram through the concentric range of the same 130 degrees, we'll produce this cyan line up here, which clearly has a much higher torque profile than just using a consistent amount of weight. Then we can drop the eccentric phase to a 9 kilogram to produce this orange torque profile that's coming back down here. So why does any of that matter? Well, if we look at the amount of work that is done in phase, per phase, we can see that using the classic mode, where the green goes up and the red comes down, we produce the same 169.4 values for work performed in the classic concentric and classic eccentric phases respectively. But when we use the AVR and change the resistance through the range of motion, we can produce 194.7 units of work in the AVR concentric phase and then drop it to 152.5, which when you do out the average of these comes out to about 173, which is more or less negligible compared to the average of what the classic mode can produce. This is going to produce a different type of animal than that.